class. We want to continue our 2025 UTME Jam Mathematics series. This is one of the very first sectional topics in the syllabus for the 2025 UTME Mathematics. Numbers, basis. Number basis. Now, in this topic, we will be paying attention to basic operations like addition of in various number bases, subtraction, multiplication, and division, and also to convert from one base to another. That's our objective. Now, when we talk about number bases, basically, generally every figure, everything called numbers in mathematics starts from 0 and ends at 9. So, by this explanation, I want to show us how figures exist in terms of number bases. So the numbers that exist in different bases have been summarized here below. Numbers in base 2 numbers are first called binary numbers, and the figures you see under these binary numbers are 0 and 1. By application, we use them in the design of switches, on and off switches in our appliances, both at home or at office areas. Numbers in base 3 are the figures you will see in base 3 are 0, 1, and 2. You can't see 3 in base 3. Okay? In base 4, you see 0, 1, 2, 3. In base 5, you see 0, 1, 2, 3, 4. Base 6, you see 0, 1, 2, 3, 4, 5. Base 7, like that, till you get to your base 10. Base 10 are called binary numbers, meaning all the figures that exist from 0 down to 9. So we therefore say mathematically that every numbers in number system exists first as a binary, because all the figures there, no matter the value, exist as a binary. Okay, now the next thing is how are questions in binary operations asked? They can ask you to simplify, they can ask you to expand, they can ask you to solve. So first of all, I will start by using base 2 numbers. So we will be treating binary numbers. These are base 2 numbers. That is numbers in base 2. A question can be asked where they ask you to expand. And when you are solving any number in bases, the first rule is to expand to base 10, basically, no matter the question. So if I say 0, 1, 1, or 1, 1 base 2, for instance, and I am asked to expand, what I will do is to say this 1 here times this 2 plus this 1 times this 2. Now, this first 2 here, which is the binary, we give it an index of 0. And this one will give an index of 1. So logically, some mathematicians or some students, before they start at all, they will put 0 here, 1 here, so that it will help them to know the indexes that they can find when they can use when they are solving. Now, if I'm solving this now, they said expand this, I can leave my answer like this. That means I've expanded. But if the question says solve 1, 1 base 2, then I will continue. And how will I do that? I will say 1 times 2 plus 1 times 2, 0 here, 1 here. 2 raised to power 2, 2 raised to power 1 means 2, plus 1 times 2 raised to power 0 is 1. We did that when we're treating indices, where we said everything raised to power 0 is 1. Okay, so with this, I will continue. Then 1 times 2 will give me 2, plus 1 times 1 will give me what? 1. Now, the answer will be 3. I can leave my answer like this, either 3, or I will say 3 base 10. If whichever way I choose to leave the answer, that answer will be what? Correct. Because I started earlier by saying that every number exists as a what? As a binary, which is base 10. Okay? Now, having said that, also, I can say they can ask us to solve 101 base 2. The idea of that, because this number is in base 2, we cannot see any value bigger than 2. If it's in base 3, we can't see any value bigger than 3. So what will I do? If I choose to do the pattern of, so that I will not make mistake, I'll write my indexes on top. Or I simply do this 1 times 2 raised to the power 0. And I say 0 times 2 raised to the power what? 1. Or here, and I move 1 times 2 raised to the power 2. That I can continue doing that. 1 times, this will be 1 times 2 raised to the power 0 is 1. And I say 0 times 2 raised to the power 1 is 2. Then I say 1 times 2 raised to the power 2 is what? 4. I continue. This gives me 1, this gives me 0, and this gives me 4. When I add everything here, this gives me 5. Is it I leave my answer as 5, or I say 5 base 10? That's how it goes. The same way, if you are asked to expand or solve in a given base, base. So I would say, if the question is 2, 0, 1 base 3, the same way I have solved, I will say 1 times 3 raised to the power 0 plus 0 times 3 raised to the power 1 plus 2 times 3 raised to the power 2. This continues, gives me 1 times 3 raised to the power 0 is 1, plus 0 times 3 raised to the power 1 is 3, plus 2 times 3 raised to the power 2 is what? 9. Then this gives me 1 plus 0 plus 18. 2 times 9 is 18. Everything here gives me what? 19. I can leave it like this for 19, or I can say 19 base 10. Then I have solved it. The same way it goes like that. So we can also solve other ones ourselves. So I will want you to solve this at home and get back to me in the comment section. So if I give this now as your homework or classwork, I could say that solve the following. Okay? I can say A, 203 base 5. B, I can say 124 base 5. You follow the same process like this, you will always get your answer. The next thing now is to allow you digest this and send your answers to me at the comment section. Then we'll pick it up. So after this operation, okay, I will now go into teaching you addition and subtraction. Then after that, will now do what we call change from one base to another. Then we treat other similar questions. Now, before we get to that point, I want you to know that in many schools or many teachers, they find it difficult to teach how the multiplication and division works. But I'm going to give you a different route on how to achieve that. See you at the next slide. Thank you.